Welcome back. In this video, we are going to talk about mass and mole conversions. How exactly do we convert between the mass of a substance you can actually weigh on the balance and the number of moles we need for our chemical equations? We are going to use molar mass values found on the periodic table to bridge the gap between grams and moles. So grab your periodic table and follow along. To do these calculations, we need to treat the molar mass from the periodic table as an actual equivalency. For instance, if the table says lithium is 6.94, that's the bottom number on each element symbol, that means 1 mole of lithium is equal to exactly 6.94 grams. This allows us to create a fraction that we can use to cancel out the units. We use a method called dimensional analysis to ensure our math stays organized. You always start by writing your units that are given to you on the left, followed by a multiplication sign, then a fraction bar, and then the trick is to place units that you want to get rid of on the bottom of the fraction bar so that they cancel out, and that leaves the desired units up on top. This is the template for the class. I would write this down in your notebook. We're going to slide numbers and units into these 3 boxes so that everything works perfectly. Let me take you through a practice problem. How many grams is 0.38 moles of lead? First, you want to find lead on your periodic table. You'll notice that we have the 207.2 there on the bottom. You want to specifically write out that 207.2 grams of lead is equal to 1 mole of lead. Step 3, you want to literally write out that whole template that I told you to write down in your notes. This is going to be the starting point, and we just want to drag numbers into the appropriate boxes here. So let's focus on the units here. You want to identify the starting units in your word problem, the 0.38 moles, and that's your given unit. Now you want to make sure the moles cancel, so for your equivalency on the bottom in orange, we want to drag down the 1 mole of lead. Okay, mole and mole are going to cancel. The other side of the equal sign goes up on top, that's the 207.2. So you want to grab your calculator and calculate the results. But before we do that, we want to just make sure that our units cancel. Moles is on top, moles is on bottom, so they cancel. So I'll leave it up to you to finish your notes with grabbing your calculator and writing the result. Let's look at this problem. What if we go the other way? We're starting with grams and we want to find moles. So how many moles is 80.0 grams of barium? Again, find your periodic table. You want to write down the molar mass, 137.33 grams of barium is equal to 1 mole. You want to write out your whole template that we're going to use continually all the time in the class. And you want to look at the word problem and bring down the 80.0 grams of barium. That's our given unit, our starting units. What units are going to cancel? The grams are going to cancel. So we want to bring down the 137.33 grams for the bottom of the fraction. We want 1 mole, the other part of the equal sign, to be on the other side of the fraction. And let's go ahead and just make sure our units cancel. Grams is on top, grams is on bottom of the fraction. Great, it works out. Go ahead and grab your calculator and calculate the result. Notice that here you're going to divide. If you don't really know the math well, it's going to be 80 times parentheses 1 over 137.33 grams. That gives you the final answer. I'll let you finish that off in your notes by yourself. The big picture is all about the mole map. That's our central hub. To get to the number of atoms, we use Avogadro's number. But to get the mass, we can weigh in the lab, we use molar mass. If you go from grams to moles or moles to grams, you're going to use the molar mass, and we find that number right off the periodic table.